All right, so here is our notes on limiting and excess reactants. So if you haven't opened it yet, go ahead, go to our classroom, click on classwork. It's going to be in Unit 8, Stoichiometry. Okay, and as soon as my computer decides that it wants to work today, it's going to be homework limiting excess reactant notes. And then you will find your copy of the Google Docs there on the assignment once you click view. And then make sure to include highlights and a 3 to 5 sentence summary on your notes, and then create a link on page 55 of your notebook. All right, so let's go ahead and get started. All right, so we've just went through all of the stoichiometry, and so now we're going to use that stoichiometry to determine what's going to limit how much I make of something, or maybe what am I going to have too much of, and so that we can make sure that the reaction works. Remember when we talked about rate of reactions again, we need so many molecules in order to collide to create that reaction to happen. So our essential question is, how do you determine which reactant determines how much product is created? Okay. If you want to do a little reading on limiting and excess reagents in your chemistry book on pages 369 to 371, and I would look at examples 12.7 and 12.8 to help you. Okay. All right, so let's look at what does it mean when we're talking about limiting reactants and excess reactants. We'll use pizza analogy to understand it, okay? So if you have one pizza and you're gonna need one crust, say you need 5 ounces of sauce, 2 cups of cheese to make one pizza, okay? Now, what if you were in the kitchen and you had 4 crusts, you had 10 cups of cheese and 15 ounces of tomato sauce, okay? Well, we have enough crust to make 4 crusts would be our given, and we need 1 crust for 1 pizza, so we would set that up, and so we could make 4 pizzas with the crusts, okay? And then we have enough cheese to make if we need 10 cups of cheese, or have 10 cups of cheese is our given, and we need 2 cups of cheese, which tells us right here, for 1 pizza. Then 10 divided by 2 would mean I can make 5 pizzas if I had just with the cheese, okay? And assuming that I had more than enough for 5 for the rest of it. How about the sauce? We also need to check the sauce. So we have enough sauce to make, how much does the sauce make? So if we have 15 ounces of sauce, and here from our balanced equation, we need 5 sauces to make 1 pizza. So 5 sauce ounces of sauce, see the units cancel, to make 1 pizza. And so 15 divided by 5, here is we can only make 3 pizzas with our sauce. So looking at the different ones, the crust that we have, we could make 4. With just the cheese here, if we think everything else is more than enough, we can make 5. And the sauce, we can make 3. Well, we can see right here that the sauce is our limiting reactant, which means it is the one that is going to determine how many pizzas I can make, because I can only make 3. Once I run out of sauce, I can't make any more pizzas. And so it's the smallest number, so that's going to be my limiting reagent. Now, when we talk about excess, that means how much do we have, the one that makes the most, that we're going to have the most left over. And so here we have cheese. It can make 5 pizzas, so this one would be my excess reactant, okay? All right, so let's look at a couple definitions too. So limiting reactant, it's the reactant that is completely consumed or used in a chemical reaction and limits the amount of product. That means there's none left over. And the reactant that makes the least amount of product, just like the sauce made the least amount of pizzas, okay? An excess reagent is any reagent that occurs in quantity greater than is required to completely react with the limiting reactant. So just like our cheese, it is the one that's going to make the most products, and it's going to have the most left over after the limiting reactant is used. And the reactant that makes the most amount of product, okay? All right, so how do we determine limiting and excess? The first thing is you must complete at least, you may complete more, 2 stoichiometry problems, solving for the same product. And then figure out how much product each reactant makes. So the one that makes the least product is the limiting reactant, okay? So let's look at a couple. And here it's just moles to moles, and we will be doing moles to grams in our practice, okay? So if 2.87 moles of nitrogen oxide and 12.67 moles of hydrogen are put into a container, how much ammonia can theoretically be produced? So here's our balanced equation. You should always start with a balanced equation. And so we have two different reactants. We have nitrogen oxide and hydrogen. So we have two givens, and we're going to convert it to moles. The nice thing is if you're starting with moles, you only need to figure out how many moles. If you have grams or they want you to take 8 grams, then you would have to do the two-step stoichiometry problem. So if we have here, we start with 2.87 moles of NO, we want to know how much ammonium here, NH3, is made. So our given is 2.87 moles. Our second given is 12.67 moles. And we want to know how much ammonia each one makes. So here we go. So we've set it up, and then we use our mole ratio. So we look to the left for our units that we have, which is moles of NO. And the units we want is moles of NH3. Then from our balanced equation, we have 2 moles of NO and 2 moles of NH3. The bottom one, we're going to have the units we have is moles of H2. And the units we want is moles of NH3. Moles of H2 will cancel, and we're left with moles of NH3. And here we have 5 moles of hydrogen and 2 moles of NH3 from our equation. So again, these will cancel to leave moles of NH3, and this will give us 2.87 moles of NH3. So 2.87 moles of NO will make 2.87 moles of NH3. Second one, the units will cancel to leave moles of NH3, and this one would make 5.07 moles of NH3. So then you would look, okay, which one makes the least, and that's what the limiting reactant would be. And it would be NH3, okay? This one is our limiting, 2.83. We go back. The limiting reagent, you can go back in the equation, is NO. It produces less NH3. And then which one is excess? It is H2, but because it produces more NH3, okay? All right, let's look at an example of a two-step, okay? What happens when we have to do a two-step one? So there's our balanced equation. It's already balanced for you. So please make sure, even on the test, that you make sure that your equation is balanced before you start with any stoichiometry problem. What is the limiting reagent when 80 grams of copper reacts with 25 grams of sulfur? So now we're in grams. So remember what I said. When you're in grams, okay, you have to convert to moles. Remember, everything on the periodic table is in moles because of that different density. And so we have to make sure we compare moles to moles. We cannot compare grams to grams in this point, unless we go, and I'll tell you, when you get to AP Chemistry, they'll show you how to compare grams to grams. But here, you have to always go to moles, okay? So we start with grams here, 80 grams of copper. And we're going to multiply by our molar mass. Remember I told you when you see grams in the equation or in the problem, know you have to calculate the molar mass of whatever grams it is in. So I went ahead and calculated that copper has a molar mass of 63.5 grams per mole, and that's just straight off the periodic table. So now I have my conversion to the moles, okay? And the grams of copper will cancel. And then now that I'm in moles, now I can go here, and the units I have are moles of copper. Units I want are moles of copper sulfide, okay? Because that is the only product. So then I will check my units, and the moles of copper will cancel. I'll be left with moles of copper sulfide, okay? So then I just do the math. 80 times 1 divided by 63.5 times 1 divided by 2, and I will get 0.629 moles of copper sulfide. So 80 grams of copper will make 0.629 moles of copper sulfide. Then I will do my next stoichiometry problem with my sulfur, and my given is 25 grams of sulfur. I have my molar mass here because grams of sulfur is the units I have, and I can convert to moles that way. And if you look on the periodic table, the molar mass of sulfur is 32.1. Check my units. Grams of sulfur cancel. Now I'm in moles of sulfur. So now that I'm in moles, now I can use my balance equation to convert from moles of sulfur to moles of copper sulfide. So the units I have, look to the left at the top, moles of sulfur. The units I want is moles of copper sulfide, okay, which is my product. I will check my units, and I just have 1 mole of sulfur from here to 1 mole of copper sulfide. The units cancel, and then I go ahead and do my math. 25 times 1 divided by 32.1 times 1 divided by 1, and I will get 0.779 moles of copper sulfide. Then I will look at them. Now that they're both in moles, I can now look at them and compare them. So, which one makes the least amount of product, which means which number is lower? And that is my lower number. 0.629 is lower than 0.779. So that one is my limiting reactant, okay? All right, so now that you've had that, you've had a couple examples, I want you to go back and process your notes, highlight any important notes, make connections to any of your notes in the left-hand column, write any questions you may have in the left-hand column, and then use your highlights, connections, and questions for your summary. And then make sure you write a 3 to 5 sentence summary. All right, if you guys have any questions, please let me know. Bye.